have a couple of students. Yeah, anyway. So let's start. Let's go ahead and write. So I'm just going to write this down. Vertical asymptote. If a rational function has non-removable, because remember one more time, vertical asymptotes are discontinuous when you're not removing a factor. If it's a denominator, that is basically from where you got the discontinuity, you got the restriction. Yes?
So according to the vertical asymptote, does the graph that you like going to make, does it not go past that?
It will not go past. So it will actually look like this. It will get close to it. There will also be a horizontal asymptote, but it will look like that, and then it will look. Yeah, it will actually have curves. Yeah, because the whole thing is not possible. Correct. Whereas this one will be look like a linear. It could even be a quadratic. You can have a hole in a quadratic. It will be a parabola with a hole in the parabola. Yeah. And if the rational function has removable, so what you have to understand is, what are you removing? You are removing factors. So if you are removing factors from the numerator and the denominator, it becomes a removable discontinuity. Okay, I just want to explain this that I'm highlighting right now before we go to the next page. So remember, when you have a hole, when you have a vertical asymptote, it's just a line. So it goes to the entire x equals to 2. But when you have a hole, it looks like this, right? It's a hole somewhere in your graph. It has an x value of, let's say, 2 or 3, let's say. I'm just taking an example. And maybe it looks like this. I don't know how it looks like. Maybe it looks like this. It has a hole. But what is this hole? Can someone tell me what this hole is? It's a point. It's a coordinate. A coordinate has what? Has an x part and as well as a y part. Exactly. I don't know what this y is. I don't know what this y is. How do you find the y? Because any time we ask you what is the whole of this particular rational function, you have to give it to me as a coordinate, because the whole is a coordinate. Don't just tell me x equals to 3. With x equals to 3, you're telling me it's a vertical asymptote. Because remember, a vertical line, the equation of a vertical line is x equals to something. So if you're asked for a whole, it has to be in the form of a coordinate. How do you find the y part? Whenever you have an x, you can always find the y by substituting the x into the equation. That's it, right? Y equals to something x. So you put the x, you get the y. So to find y coordinate, plug it into the simplified form of the equation. Okay, this is important. Plug it into the simplified form. If you plug it into the original equation, you will get 0 on the top, 0 at the bottom. Because remember, those factors are cancelling out. So it has to be into the simplified form. And when we do the exercise, it will obviously get clearer. Alright, can I go to the next page? Anyone still writing this down? Yes.
I have a question.
Sure.
About the hole. So what's the difference between a hole and an open coordinate?
It's the same thing, except this is a restriction. And that's also a restriction. So it is all the same thing. It is the same thing. It's basically your graph does not exist at that particular point, which is true even when you're writing, putting an open circle on a graph. So it is the same thing. Okay? Alright. Good question. Alright. Moving on to the next page. So now we're doing some exercise. I'm going to do the first one with you guys, and you will do some of the others by yourself. So it says state the domain, points of discontinuity, and of the. So basically they're asking for all of this. So you always start, when you're given a rational function with a numerator and a denominator, you always start by fact. Whenever you see any polynomial, doesn't matter if it's in a rational function. Whenever you see a polynomial, if something can be factored, you should factor it. That solves a lot of the problems. That basically gives you a lot of solutions. So in this case, my numerator cannot be factored, right? This is just written as x plus 3. Can we all factor the denominator? Because I know there is some restriction. I cannot find the restriction unless I factor the denominator. Can we all factor the denominator? Factors of 3 that add up to -4. Perfect. Negative 3 and negative 1. Is there any factor that's getting cancelled? Not really. So I'm going to straight away say none under the holes. I'm straight away going to say none under the holes, and remember, holes is the removable factor. Because we're just learning, let's write that down. Hole is removed because you get the hole by, so there is no hole. Okay. What are my restrictions? X cannot be equal to, so let's write that in a domain. All real numbers, right? And X cannot be equal to positive 3, and X cannot be equal to positive 1. If we can write them together too. You will write the domain in this form. Is everybody good so far? You will write the domain in this form, but the point of discontinuity is, it is so that you have to kind of understand the fine difference between the two. Point of discontinuous is my graph is discontinuous at x equals to 3. So here you don't say not equal to, and x equals to 1. Okay, so just note the difference between how you write it. That's all. Discontinuous at 3 and 1, or 1 and 3. It is, and this discontinuity is non-removable. This discontinuity is non-removable. It talks about infinite. We are going to ignore that. I haven't talked about it, but we are just focusing on removable and non-removable. And then the last question it asks for is asymptote. So basically, all your non-removable asymptotes are all your non-removable discontinuity are all asymptotes. So VA basically stands for vertical asymptote. So if you want to write that down, you can. So VA always stands for vertical asymptote, and you have vertical asymptote at x equals to 3 and x equals to 1, non-removable. Because those factors are not getting cancelled. Those factors are not getting cancelled. Okay, I'd like you quickly to do 2. Actually, no, just hold off 2 for 1 second. Let's start with 3. Let's start with 3. You guys can see 3 here. We'll start with, let's do 3 and 4, both of them in succession. I think the more we practice, the better. Alright, can we all look at what I filled in? I factored the numerator as x minus 4, x plus 1. Everybody good with the factors? After I factored, what do I see? X minus 4 and x minus 4 gets cancelled. So my equation is actually just h of x equals x plus 1. But the x minus 4 in the denominator, which has got cancelled, is my point of discontinuity, correct? Which basically means my domain is all real numbers where x cannot be equal to positive 4. X minus 4 is a positive 4. Is it removable or non-removable? It is removable because I cancel that factor. Okay guys, keep in mind sometimes we'll have a combination of removable and non-removable. Also, we will see that. We will see that. So that's a whole. So I straight away said there are no vertical asymptote, because vertical asymptote are basically non-removable only. And I don't have non-removable, right? but I have a hole because hole is removable. I keep telling myself that because I'm just learning. Hole is removable, vertical asymptotes is non-removable. So remember when I said whenever I ask you for a hole, you have to give it to me as a coordinate. So how do I find my y given the value of x? Yes, go ahead.
You plug in the x value into the
Simplified, excellent. You have to plug it into the simplified. And I'll tell you why. Let me find another piece of paper. And I'll tell you why. Let's try to plug it into, find value of y, let's try to plug it into the actual equation. H of x, and I have factored it, let's try to plug it into the original. X plus 1, x minus 4. Correct? This is my original equation. Whether it's this form or this form, doesn't matter, they're both the same. If I try to plug in, my hole is at 4, I don't know, I'm trying to find this. If I try to plug 4 into my original equation, what happens? 4 minus 4 is 0, correct? 0 in the denominator, not possible. And this also becomes 0. So it's not, so you always plug it into the simplified one, which means x plus 1, which means 4 plus 1, which means 5, so it is 4 comma 5. That is why it's important I put a star, you have to plug it into the simplified. Most of the students remember it, I do have sometimes the answer whole as 4 comma 0. I do see 0 showing up here because they substitute in the original equation. In the original equation it's actually undefined, but the numerator is 0. Alright, so please keep that in mind. You solve for y by plugging it into the simplified equation. Okay, let's go ahead and do 4 now by yourself. Yes. Yeah. Give me one. Always a little easier when it is a vertical asymptote because you don't have to solve for y. It's an equation. It's literally b, my graph will be at x equals to 4, it will be a vertical asymptote, at x equals to negative 4, it will be a vertical asymptote. So there's no question of a hole, it's basically 2 lines. My rest of my graph will work around that. And we'll see, we'll obviously I'm going to graph it, but for now if you can understand this, that'll be great.